The deep sky object in Hydrus is NGC 602, which is the flying lizard. As you can see, this one does kind of look like a flying lizard. And a close-up of that region shows a star formation region with a beautiful cluster of newly formed massive stars. And those stars are emitting copious amounts of ultraviolet radiation, which is emitting a lot of pressure on the nearby gas and dust, and it's pushing it away and clearing out the area around these stars. And when that happens, it triggers, as you can see on the edges around it, you can see the pillars of gas and dust above it and below it, and that's actually pushing that, causing that dust to clump up and become more dense in places, triggering another round of stellar formation. Leo has the star Regulus, which is actually a 4-star system. Regulus A, the main star, what we think of as Regulus, also has a white dwarf companion. Lyra has Vega, one of the 3 bright stars in the Summer Triangle constellation. Monoceros, the unicorn, lies between Orion and Canis Minor, and it contains a deep sky object, the Rosette Nebula. And here are 4 images of the Rosette Nebula. Now, these are actually astrophotography, because you should not forget that there are so many great ground-based telescopes, and these aren't even big ones. These are produced by amateur astronomers with as small as 12-inch telescopes in their backyard. But the optics are so good that they can take these kinds of images of these objects so far away, and you can see a huge amount of detail. You can see the star formation pillars in there. You can see the reflection and the emission nebulas, and the clouds of gas and dust, and the newly formed stars in the center region. Another constellation is Ophiuchus, and Ophiuchus is the 13th zodiacal constellation, because if you see down at the bottom, the red line that has the months on it, January, there's December, there's November, that's the path of the ecliptic through the sky, and it actually goes through the constellation of Ophiuchus. And so if you were born on sort of like between November 29th and December 18th, you're actually an Orphiuchian, the serpent holder. And also in this particular constellation, we have a star called Zeta Orphiuchi. Now there is, the arrow shows where this star is. It's not the brightest star in the constellation. However, it is the most interesting, because Zeta Orphiuchi is actually sort of a runaway star. It's all by itself, all by its lonesome, plowing through space-time at 24 kilometers per second, moving so fast that as it moves through the interstellar medium, it's producing a bow shock, pushing up the gas and the dust that's in front of it into the shock wave in front of it. And it is thought that this star, and this is a massive star, it is an O star. There are very few O stars, very, very few. They're very, very rare. And this is an O 9.5, which is almost a B, so it's just barely an O-type star, but it's incredibly massive. It's still a main sequence star, and so it's very, very young. So it is thought that it must have been in a binary system with another star, a companion star that did collapse, and that collapse was so catastrophic and produced so much energy that it basically just flung its companion star, Zeta Orphiuchi, into the interstellar medium, and now it's out there on its own. And of course we have everybody's favorite Orion with Betelgeuse, which is an M luminosity class 1, which means it is a very luminous supergiant. It is now that it's a spectral class M that should go supernova any astronomical day. Also in that constellation is Rigel, And Rigel is actually a triple star system, and all three of those stars are B stars, so they're all very, very massive, very, very bright. But they are, Rigel itself proper is now a luminous supergiant, and its two companion the binary pair, are still on the main sequence, but they're all B-class stars. And of course we have the Orion Nebula, which is the bright area hanging down in the sword below the belt of Orion. And here are 5 different images of the Great Orion Nebula. As I said, it's a very famous star formation region. It is observed and analyzed a lot. It has a group of stars in the middle of it called the trapezium, a cluster of stars, newly forming stars in the trapezium, and it's only 1,500 light years away, so it is observed a lot by all wavelength missions. But once again, the 2 images on the left-hand side are astrophotographs from amateur observers here on Earth in their backyards. The one on the upper right is a Hubble image, and just below that is a blow-up of the trapezium area where star formation is taking place. And it is on the same scale as the Chandra X-ray image right beside it to show the difference of what an object looks like in the optical versus the X-ray. And the X-ray not only shows up the massive stars in the trapezium, but all of those blue spots around it are other protostars that are forming in that particular region that are only visible in the X-ray at this moment. Perseus, the star Algol, which is the prototype of all eclipsing binary stars, is a triple star system. The major star, Beta Persei, is eclipsed by Beta Persei b on a regular basis, producing that very famous eclipsing binary light curve exhibited by all eclipsing binaries. Sagittarius is a constellation that lies towards the center of the Milky Way galaxy, and within that, of course, is where we find Sagittarius A asterisk, our own galactic-sized mass hole. This shows the Sagittarius, called the teapot. It lies next to Scorpio, and the Scorpion in the sky, and it's not too far away from Altair either, another star that you're responsible for this year. And in the actual disk of the galaxy, this is an X-ray image from a survey that it took of the center of the Milky Way galaxy, showing the location of Sagittarius A. There are also 2 star formation regions in Sagittarius. One of them is the Omega Nebula, M17. You can look at the difference in the distribution of the gas and dust, and so much of an emission type of nebula versus a small amount of reflection. So that shows a difference in how rigorous the star formation is in this particular image. And here is a close-up of the Lagoon Nebula, another star formation region. Of course, there is a lot of stars towards the center of the Milky Way galaxy because you're looking through all of those arms towards the center. So there's a lot of star formation in that direction. Scorpius has Antares as its major bright star. It's orange-y, very orangey, because it is now an M classification luminosity 1 star. So it is a superluminous supergiant. And here's another image of it. It is the orangey star that you see there. And you can see some of the dark molecular clouds within that star formation complex surrounding it.